Welcome back to another YouTube video in regards to Yamaha's YZF600 and YZF600R Thundercat. In front of you here we have an example of 97 plus carburetors, meaning Thundercat carburetors, also meaning they have ram air and are 2 millimeters bigger than the US-based 95-96 YZF600 and the UK/United-based 94 through 96 FZR600. Main differences you're going to notice is that the top snorkels are gray instead of black. They have these pressurization tubes here, or part of the ram air system. On the non-ram air bikes, these are just vent tubes and they point straight down. They don't actually link up. There's a filter that would be center here that then links up to the air box for pressurized air to come through. Overall, they're the same basic design, the same spacing, the same diaphragms, so a lot of the carb parts swap over, same floats, valve and seats, spring assemblies in here, choke assembly the same. Jets are different between them. These are much bigger jets than what the non-ram air bikes would have. And then of course these throats, the inside diameter is 2 millimeters bigger. Purpose of this video is these are my extra set of carbs. As mentioned, these are 97 plus carbs. I had these with a modified airbox on my 96 YZF600. With a lot of tuning, I was able to get a little bit more peak power out of it. Mid-range was a little finicky, but mostly it was pretty sensitive to temperature. It was easy enough to live with, but recently got another bike. Power doesn't matter so much anymore. I decided I wanted to put it back to stock. My stock carbs were put away, cleaned and tuned, supposedly ready to drop in. So I swapped the carburetors and the airbox to put it back in there, only to find that I had a leak on one of my crossover tubes on the 96 carbs. So this is your fuel rail assembly. There's two of these plastic pieces that link each carbs 1 and 2 and 3 and 4 backward. Yes, 1 and 2, 3 and 4 together with your fuel supply from your tank down here at this nipple. It's fairly common here for that to happen. For me, it was leaking at the seam of this T-joint here. This plugs into that side there. It's also common to leak side to side here where it goes to each carb body. And then for me it was this rail here, and it was just gushing fuel pretty bad. Didn't have that problem going in, well, last time they were in. So when I installed them, I stole parts from the 97 bank here, and this was the busted part from the 96. And being they're interchangeable, that's nice. So what that means, though, is when you have a leak like that from one of these unions, or possibly you could also be leaking out one of these pressurization tubes, because they also have O-rings in them. However, to leak out of here, you would have to have really bad floats, because you'd have to be flooding pretty bad to make that happen. But you would definitely have running problems if that were to be the case. And also having a leak in the air side of it wouldn't be great either, so that is another possible cause of some carb tuning issues. These little buggers, you can only buy them as an assembly. And they're something around $70 per. If both were leaking, there's 140. I mean, even this little T union here, I think is like 30, which is ridiculous. That's just a T. There are some nice special things with that. But it just goes to show how specialty motorcycle things can happen like that. But I was bound and determined to take this apart and actually see if we could rebuild it. It's discussed from time to time. Some people have just bought a box of random O-rings, shoved them in there, see what they are, see if they can fit. And some people tell you that it works, some people tell you that it didn't, or they never post up to tell you the results. I decided it'd be worth doing it since I have it here on the bench, and I'm not actually trying to solve my problem. My problem's already solved because I had another part. So these are just sitting around spare. And maybe we can do some other videos with these carburetors since they're just kicking around the shop now. With any fuel rail leakage problem, you're going to have to separate the carbs. Most people don't even separate them when they clean them for fear of when we take this apart, these seals might be bad, and then I put it back together, and I used to not have a leaking carburetor assembly, but now I do have a leaking carburetor assembly, so that's a risk that some people often judge and weigh the pros and cons of that and decide not to split carbs when they clean carbs. So does it really count as a fully clean carburetor? Debatable. My personal opinion is don't break them apart unless you have to, but others are going to say it's not truly clean until you do. But not everybody has to deal with situations like this where parts are rare, hard to find, or expensive. So each person must make their own decisions. If we notice here, if you are going to be separating your carb bodies even just for cleaning, but we're going to have to separate them to try and address our leak issue, you need to separate them from the rail assembly, and then there's a big rod, a threaded rod that goes through. This is the nut of it. That's the head of the bolt. A bolt that passes through this entire length in order to pull these off individually, as well as they are Phillips screwed, technically Japanese industrial standard screws, holding it to this rail. You notice I have different hardware here already. I previously took this off and did this as an example. This is a new Phillips piece of hardware, and this is an Allen cap head screw. Oftentimes people will replace all of the Phillips with cap head screws because they're easier to deal with in the future, because these suckers are on very tightly, and we're going to go over some ways to remove them. And you might have to replace them with new hardware if you goober them up real bad, but there's always ways to get things out. Unfortunately, they're very accessible on the outside, but they are incredibly tight. So tight, you probably won't have any luck taking them off. Hopefully the most frustrating part of this entire process will be dealing with the rails mount. If you've gone in here before, like, and I have a shiny new screw here, most likely you're going to be able to get away with just a Phillips screw driver and spin this out as you would any other screw. Or possibly you've been in before and you did an upgrade to cap head screws. Life's nice and simple. So we can actually get this carburetor off very easily because I've already had it off, of course. And life will be good. But then, if it's your first time getting one of these out, I want to get that out of the way. I've already cracked this one loose, so maybe you get lucky and you push down super hard and you give it a good turn, you might be able to get it. Or you could use a mini electric impact with a Phillips on there. Might strip it out. Or a hammer actuated one where you would cock it, place it on the screw head, hit it with a hammer, try to rock it out that way. All those things might work, but you might end up fighting it more than it's worth. For me, what seems to be tried and true when you have one of these suckers that are really tight, based on the head accessibility, small vice grips on here, clamp it on quite tight. So I'll hold your rail and do that. And you can crack them all loose that way and then easily get them out with your screwdriver. And they don't need to be that insanely tight when they go back in. Also, there isn't any Loctite or any type of thread sealant on these particular ones. They go into a blind hole. There's no reason for any thread sealing, just to hold them in a rail so the carbs stay aligned, so for mounting purposes. So once you have this out, you feel free to upgrade to a cap head screw. And if you're curious about upgrading to cap head screws, these are an M5. I'm using the caliper here, and they're an M5 screw, and they are 14 millimeters long. So they are an M5 by 14. You could get away probably with a 12 to even a 16 in length, but M5 14 would be the correct one, and you could get that in the cap head or a new Phillips. The main point is we got the two off that we needed here, so we can try and separate that carb from the rest of the rack so we can get to our leaky union. Next we need to undo the 8mm nut at the end of the rail assembly here. And it's an 8mm head on the opposite side as well. Any socket or box wrench will work fine for here. This has already been cracked loose, so I'm going to spin it off by hand. So now we have a nut, and there's a very long rail that goes the whole width here, which you don't necessarily have to remove completely, but just so you see what it looks like, it's just a very long bolt. Set that off to the side. Now that our carburetor is free from the rail and free from the rod, we would now separate it from the rest of the carb assembly. There are O-rings in place here between us. You might have to give it a wiggle and a rock, and there is a spring that goes between the carbs. There's two possible springs that could fall off while you do this, but they aren't going to go flying. They're not under that much tension, so let me just rock this. This is going to be easier than yours probably would be. Excuse me, I did forget something. We've got to get the choke assembly off. Choke slide has to come off. It's just a Phillips. Spin that off. There's a nylon spacer on all these choke slide screws so that the mechanism can work underneath the screw head. Pop that out. Sometimes you might need to do two to flex it out, but you can usually just give that a little pry, especially when we're just dealing with an outer carb. If you're splitting the whole bank, you would take all of these off. pull that whole rail off. Very easy to do if need be. So we have this, we have that. This is the screw, this is the spring. This little spring here just keeps some cross tension on it. You can easily squeeze and just remove that one. There's also a spring here that goes on the two blades. It's about ready to fall apart though. There's the, for the synchronization, this is the synchronizing adjustment screw, and then below that there's another spring that puts tension on the lower flap. That this is loose now because it's not pressed against this plate. I'll try and get you some better close-ups during assembly process. But here's another spring, and I'm just going to put it off to the side. And then we just wiggle this apart. Now we have one carburetor separated from the rest of the rack. This is that cross pressurization tube. I'm going to pull that out, set it aside. Our fuel assembly here has a hose clamp on it. I'm going to undo the hose clamp, slide it off, and then I will wiggle and pull this sucker off. Cool. And that is removed. I'm going to get the carburetor bodies out of here, the ones we're not dealing with, off to the side, and we'll bring this one front and center here and get resituated. Here's our lonely, all-alone carburetor. This would be carburetor number 4. This side here is what actuates the butterfly. So we know this side here is the one that goes with the rest of the carbs. So we go 4, 3, 2, 1, going away that direction. Here we can see mixture screw, nice and front and center. That's kind of fun. There's nothing here that's going to fall out at this point. I would point out that these are the holes, so this is for the fuel, because it's down by the float bowl, plugs in there. Our fuel crossover, our T-fitting plugs down into here. And our pressurization fitting, this one, would plug in up here, like that, to keep positive air pressure. At this point, for dealing with the leak, I don't really need to do anything else with this carburetor body. You don't need it until it gets reassembled. Here is where the throttle position sensor would go. You can see how it moves when I move the butterfly valve. The 96 doesn't have one, so I just removed the TPS from this carb assembly. No trouble doing it that way. If you had a 97 Plus and you were trying to run 96 carburetors, you'd probably have to spoof that signal somehow, because there wouldn't be any way to adapt a TPS to the 96 carburetor, at least not very straightforward. So I'm going to set this off to the side, and we'll look at these tubes. This tube, the air pressurization tube, is just O-rings. They plug in, they slide on these rails here and here, and they were completely deteriorated when I pulled it off. I didn't even expect that, being that it wasn't leaking fuel out of there. Of course, it would just been an air leak, but they were definitely crumbly, so I should replace all the O-rings in this whole carburetor assembly, most likely, based on the age of them. But it's quite easy to get to once you pull this apart, and you would just slide on an O-ring, and it would rest in the groove, and then in the groove. I'll get you the O-ring dimensions here in a little bit, but this one's pretty straightforward. The expensive $70 fancy T-fitting is a little more involved, in that from factory, if I hold it here, there are tabs that would go here over and here over, preventing you from squeezing these tabs here to free it up. They didn't want you to open it. Once they clicked this in once, it wasn't intended to come apart. So let me grab this one here, the one that's still on the carb assembly. You kind of see what I'm talking about. There's one of those tabs on either side where my fingernail is. So I took a Dremel and I just cut those tabs off. Use a hacksaw, you could even use a file, maybe a nipper, to get those tabs off. And that way you have free access to separate the upper and the lower half here. The O-rings on the left and right, these are the parts that go into the carb body itself, as accessible as the air pressurization tube as well. There are 2 O-rings per side. Again, these are all just crumbly, so they're gone. They're not currently on this part. But you can see where the grooves would be, for where that would go. But my leak was actually in this seam here, in this union, so I did have to cut those to get them off. But there's no harm in removing them, and you still get the spring retention of the clip, which I will give a wiggle. And I might need to do this off camera to squeeze and use a little pry tool. for you. And give it a squeeze and a little pry. There we go. So we will move this off. Separate here. This is just tube, molded, nothing left on that side. O-rings up here. My leak is coming from the O-rings in here. There are 4 O-rings on here as well. 2 per post. And 1 has been removed already before this disassembly for sizing, and that's what we can do. If we could replace these O-rings and get a seal, we don't have to buy a $70 part or donor carburetors or anything like that. And in my mind, there's no reason why we can't get these seals. So we'll investigate those here in a minute. Here are some of the O-rings that I've removed from my leaky carb assembly. The ones that are actually broken and kind of ripped are from the pressurization tubes. This one is from the inner seals. My part that was actually leaking was the smallest of these. These are from the air tubes, and then this is from the top of this T. There's 4 of those 4 there. O-rings generally are measured by cross-section. So when we cut one in half, or we have one that's torn, when you look at it on end, that would be the cross-section measurement. That's not going to focus because that's awfully tiny. But O-ring on end, or cut apart and then just laid out and then measured cross-section. And then usually inside diameter. Generally speaking, O-rings want to be circles. They are not called O-rings because they're circles. They're called O-rings because cut in half, the cross profile looks like a circle or an O, and that's how you get like an X-ring chain. If you cut that in half, look at the profile of the seal, it'll have an X profile. There are many other shapes as well of seals. But for our purposes here, they are also circles, so we can measure them, and I have a caliper. The seals are a little bit weird and a little harder to come by than some others because these are all 1.2 millimeter cross-section O-rings with various inside diameters. For example, the diameter of the internal seal that plugs into our T-fitting, the one that we separated my leak, is a 5 mil inside diameter. So the correct O-ring for this would be a 1.2 millimeter cross-section, 5 millimeter inside diameter ID, and that would fix my leak if I could find those. The bigger ones, again 1.2 mil cross-section, are, I believe there's 7. Yeah, let's measure here. Yes, our 7 would be for the T here, and here, be 1.2 millimeter cross section and a 7 millimeter inside diameter for that one. For our pressurization tube, I think these are also 7. Yes, also 7. So 1.2 millimeter cross section by 7 millimeter outside diameter, and you can replace fuel pressurization and your tire fuel delivery system. So you could quote unquote rebuild your whole carburetor. There are 4 1.2 by 7 millimeter inside diameter O-rings on the outside fitting, and then there are 4 1.2 millimeter cross section 5 millimeter inside diameter O-rings in here, so meaning there are 8 O-rings per fitting, times 2 of these, 16 O-rings, and there are 2 of these times 2, so that'd be another 4, so for 20 O-rings, you should be able to rebuild all of this for reasonable, right? Maybe somewhere even $8 maybe in O-rings, considering shipping and what they should cost. But there's our problem. Where do you get them? What kind do you buy? And 1.2 honestly is hard to find. I have found a standalone eBay auction for 1.2 cross section with a 5 millimeter inside diameter, $5 for 4 of them. Pretty reasonable, I guess, considering it's the only place I could find them. The usual place I buy O-rings is the oringstore.com, which has a really great selection of metric O-rings, which is what we're trying to buy here. But the 1.2s, they do sell what we need, but the minimum quantity order is something like 400. So that wasn't going to work for me. So we're going to have to investigate what other O-rings might possibly work for us in this situation. So I wanted to figure out an alternative that people could get readily and reasonably priced, because we know what they are. There is no magic behind them. They are 1.2 millimeter cross section in various diameters, 5 and 7 millimeter diameters, and they need to be a fuel safe O-ring, which Buna, B-U-N-A, if I'm saying that correctly, is highly fuel safe, which is a very common O-ring for automotive applications, and you can get them in that. Downside of Buna, why I feel stupid if I'm saying that wrong, is that it isn't as heat tolerant as others. So generally speaking, when I deal with carburetors and O-rings and engine O-rings, I go with Viton, which I believe is a DuPont-based product. And Viton is almost as fuel safe, to the point where you're not going to worry about it. It won't break down in gasoline, same as Buna, but it has a much higher temperature tolerance. I believe they can go to 400 degrees Fahrenheit in the working temperature and can be exposed to even as high as maybe 550, 600, which your carburetors do not get that hot. Buna, I think, is somewhere around like 200, which again, your carb shouldn't get that hot either, but Viton is likely what the factory used. And they come in, O-rings in general come in a different hardness factor, listed in D. Standard hardness for an O-ring is 70D, but you're not going to find a Viton in a 70D very easily, so these are all 75D Viton metric O-rings from the oringsstore.com. I just bought a bunch of different sizes because my measurements O-rings stretch and flex over time, so I wasn't 100% confident in my quick caliper work and guesstimation, so I bought a bunch of various sizes that were easy to get. And moreover, when you're able to readily find them, they end up being 8 cents to 12 cents a piece, so I decided I would risk the $10, $12 to buy all these, and we'll see what will work best. For us in the future, people just know what size to get, even though we know the correct sizes, but they're just harder to come by. If you find a good source for them, please share with the community. What we find here is that these are all 1.5 millimeter cross section, so slightly fatter, and we have a 4.5, a 5, 6, 6.5, and a 7. This down here is the only 1.2 millimeter cross section that had easily available, which is a 4 mil, which is too small. And then everything on this side is a 1 millimeter cross section with a 5, 5.5, 6, 6.5, and 7. 1 millimeter is too small. You won't get any sealing action out of these, so all of these can go away and save them for a future project if I ever need tiny O-rings. They're not small enough to be mixture screw O-rings, so who knows if I'll ever get to use them, but perhaps in a fuel valve and seat. Slide these over. Again, this is the 1.2 cross-section ones, which the few sizes they stock that I could buy in a small quantity. That's only 4 millimeter ID, so we can't use that one either. So it leaves us with these 1.5s, and I've already pre-fit them, and I know that several of the sizes will work. We're going to go slightly undersized with them because they will stretch. Stretching out the O-ring makes the cross-section slightly less and still fit well and make a good seal, even though we need a 1.2 and these are 1.5. If we stretch them out, they get really close to the overall outside diameter they need to be when installed. I'm going to start this resealing project with the part of mine that was actually leaking, the lower union that clips into the T, with these 4 O-rings stacked, of which a couple of them had to be leaking. I couldn't really say exactly which ones were, but when you pop them off, you'll see that they are no longer round in cross-section anymore. They're very much oblong to even square because they've been compressed for so long. They've lost their sealing ability, so they all could very well be leaking. And certainly, at least one whole side has to be, because they are double O-rings, so one should always be able to seal even if the other fails. But what we'll notice here is, again, these are supposed to be 1.2 cross-section by 5 inside diameter. What I found to be the correct size of what's available easily and cheap are, again, these are 75D Viton O-rings, and these are 1.5 millimeter cross-section with a, wrong package, 1.5 millimeter cross-section with a 4.5 millimeter inside diameter, so slightly smaller than they're supposed to be. So we'll stretch them over it and they'll get a little thinner in the middle, and they'll still make a good seal for us and be fuel safe and have good temperature resistance. The first step then, though, is to get these old O-rings off, which can be challenging, so you definitely want a little pick to even get in there. It's not the most exciting thing to see somebody take off an O-ring, but I will do it here for you. And I don't like to rip them off if I don't have to, so it's best to just get under it slightly and then roll it up. There we go. discard pile. 2 more on this part. Stab yourself in the finger. That hurts. I didn't there, I just missed. But it made me think of it. Oh, another one. I guess it might be interesting. So here's an O-ring. We still have one on here. Let's get a rough estimate of what the OD of the whole O-ring installed on this part is right now. And this is going to be very rough. So 7.43-ish or so. So our new O-ring should be a bit fatter than that because this one's scrunched down over time and not sealing, so we should have something probably more like 7.5, 7.6 with the new O-ring installed to ensure a good seal. While we're thinking of it, we could even measure the bore of this thing. However, it's a tapered bore. Let's see. The bore is 7.42, but I do believe it has a taper to it. Yeah, so I'm getting in there as far as I can. But it's something around like a 7.1, 7.2-ish. So if you had a 7.5, 7.6, that would give you what? This is in hundredths of a millimeter, so a couple hundredths compression on your O-ring seal. Whether it's right or wrong, I don't know. But the point is your seal should be a bit bigger than the bore you're going into if you expect it to seal. So we've stripped these down. Here's our 4 1.5 mil cross section, 4 mil inside diameter O-rings. It'll go on this part. I use just a little bit of lithium grease here, and I like to grease the posts up a little just to ease the new O-rings on there, and I do grease the O-rings as well. It does make it a little slippery to get them on, but it helps them in the long run, and you'd want to do this before putting them in the bore anyways for sealing. But because of these tines here, it's difficult to actually grease them around at that time, so I grease them ahead of time. Because they are a little small, and then we're going to have to stretch them, it can be a little tricky to get them on, but just kind of hook one edge, and then work it down with your finger, and it'll get there. Usually the top one will go on first, and you might think, oh, maybe I should shimmy it down, but if you leave the top one in there, it prevents the second one from getting stuck on that first notch, so it's easier to get the second one in by having the top installed first. So there's 2. 3. Come on, maybe a little booger. There you go. And there's 4. For kicks here, let's measure. Zeroing out my guesstimators here. So like 7, 8-ish. It's probably a little fatter than a 1.2 cross section would end up being, but I think we'll be just fine here. I'm going to clean out the bore of this here just with my pick, see if there's any dirt in here, debris. I don't think there is. And I will do a little down grease here on the opening so we don't catch an edge going in. There is no front, back, right, left of this thing. You can install it either way, and then you can always flip it depending on what side you want to use this for. The part is universal. But we got our new O-rings here that are slightly fat, but all 4 installed. And we're going to try and mate them here, if our camera would focus. To give them a little wiggle. Excuse me, my hands are slippery. Trying to get this in camera for you, but I might not be able to do that. Sorry, again, it's slippery. But we're getting it in there. had to do that off camera. It was too slippery to force the ends together. It took a little muscle. I'm not super strong, but I was able to put it back together, so you should be able to as well. You can see our clips are clipped. So at this point here, we need to do these outside ones, which I believe we are using a 6 mil. Yeah, I believe the 6 mil 1.5 worked better for this. Grab these, a couple of these. Could be wrong. I'll tell you if I'm wrong, but we'll see how these end up working out. This one being exposed, I'm not as concerned about getting the grease on ahead of time. Because I don't have the... Yeah, this is a 1.5 by 6. If you hear that, there's a band playing outside. People are going nuts. I don't really know who it is, but they're not part of our informative video. I'm going to grab a carb body here, and we know this goes in this way. Let's see if it'll fit. What do you know? It'll fit. So we should be able to seal with that. Pop that out. And I believe we'll use the same 1.5 by 6 mil 75D Viton Orings for this air crossover pipe. I think this was the same diameter, or maybe this was smaller. I don't remember. Grab the pick. New O-rings are installed inside the piece. The halves are pushed together. New O-rings on the T of the piece, and new O-rings on our pressurization tube. These are the same, 1.5 cross by 6 millimeter inside diameter, and then the internal ones we did a 1.5 by 4 millimeter internal diameter. So each of these are a millimeter smaller than the equivalent 1.2 cross section would be, and maybe a little snug, but they definitely seem to fit. And as long as everything goes together, we shouldn't have any problems with sealing, so we're going to figure that out now. Your fuel parts and everything in there ahead of time and held together. So I'm going to add a little bit more lithium-based grease here. I mean, petroleum jelly, whatever. I don't think it's going to be that crucial as to what you choose to lube this part with. But we're going to push it into this carburetor. Perfect. And it went in. And then we're going to hook up this fuel line here. Might help hold some things together. I won't put the clamps in just yet. And then our air tube. Side. big spring we can pretty much get on anytime we want. The smaller spring that makes life more difficult. So don't line up our tabs then. Work this down. Off to the side. Try to squeeze this together. That sounded good. There we go. Put our rod through here. That might help hold this together. I'm still a little off. You can see. And you can definitely see it here on this side because our rail screws aren't lining up. Let me put this little cross spring in first before it gets too tight. This is not part of this tutorial. Throw one of the caps right here, and it fell out when I was moving it around. And now it's back in there, but it'll probably fall out again. Anyway, squeeze this together. Work those O-rings in. Oh, I see. I see the problem. We're in on this carb. We're not in on this carb. Pull it over. Hung up. It's all the way in there, but not all the way in there. Suppose it could be this hose getting in the way. Knock the hose off. Here. Sorry gang, the rack got away from me there. Slipped out of my hands and I had to kind of finish this off. Camera realized I was putting it back together and I was just kind of blocking it anyway. No harm, everything's cool. But here's our fuel rail piece in position, and our pressurization tube in position, and our choke is assembled and working like it should. And our throttle is also together and working like it should. So that's all well and good. No more leaks now. What we learned here is the 1.5 is going 1.5 cross section and 1 mil smaller in our sizes, meaning a 1.5 mil cross section with a 4 millimeter for the internal ones of the T-fitting, and then a 6 millimeter 1.5 mil cross section for all the others involved, allowed for a fine seal of a 75D Viton O-ring, which is a lot easier to come by. Was a little tight pushing it back together, especially with slippery hands, and maybe you want a buddy. If you had a whole rack to do, I'd recommend doing like these two together first, and then those, don't try to squeeze it all together at once because that was a little tough to manage at the time. If you could get the 1.2 millimeter cross section in a 5 millimeter and a 7 millimeter inside diameter, which are the correct sizes in a Viton, which do exist, it's just finding it in the quantity that you want to buy. Buy those if you can. But if you can't, or don't want to spend the money or to buy hundreds of O-rings, the 1.5 mils will work with a little bit of lube and just a little bit of pushing. It's not that difficult to get them in there, and they do seal when all said and done. Yeah, hopefully that can save you 70 bucks or buying a parts carb. And with that, we'll leave it be. You know, since I have these extra parts carbs that are 97 plus, which is more applicable to most of you guys, when most of my stuff is about 96, while they were very similar, not necessarily exactly the same. Is there anything special anybody might want to see with these? I suppose we could do like a full breakout, carb clean, jet kit. I mean, that stuff is so common, people see it all the time, but it is a carburetor that you probably have in your bike if you're watching this video, so I guess if you had something specific you wanted to learn or see, I'm not necessarily the be-all end-all expert, but I do have spare part on my table that doesn't have to go into a machine, so we can kind of do with whatever we want with it. At this point here, I don't intend to ever do the 97 plus again airbox. It was a lot of fidgeting, it made a difference, but it's just without putting in a lot of money in the dyno sessions, it really wasn't paying off in the long run. So I just put it back to stock, and it simplifies the plumbing underneath the bike as well. And being that I have an R1 right now, I don't really care about trying to get every little bit of power out of my 600. And with that, if you have some suggestions, post them up. Maybe we can get to them. Thanks.